You've probably heard all about Ozempic, right? It's been all over the news for its impact on diabetes and weight loss. But today, we're looking at something else entirely, a hidden, unexpected power that could be a total game changer for protecting our eyesight. So that brings us to the big question. Could a drug that's already so well known for one thing actually help prevent blindness? That's what we're going to explore today. We're diving deep into a new lab study that suggests its active ingredient, semaglutide, could be a powerful new weapon in our arsenal against a leading cause of vision loss. All right, here's our game plan. We'll start by talking about a common and serious complication of diabetes called retinopathy. Then we'll get into the exciting stuff, the breakthrough lab study. We'll unpack how this drug seems to protect our eye cells, and finally, we'll hear what the experts think about all this. So first things first, let's get a handle on the problem itself. Because to understand why this new research is so important, you have to appreciate the scale of what we're up against. This isn't some rare condition, it's a silent threat to the vision of millions and millions of people. Let's start with the big picture. Right now, a staggering 11% of the entire world's population is living with diabetes. Just let that sink in for a second. That's more than 1 out of every 10 people on the planet. And here's where it directly connects to our vision. Of all those people with diabetes, researchers estimate that a full 40%, that's almost half, go on to develop this specific eye complication. And diabetic retinopathy is no small thing. We're talking about damage to the really delicate blood vessels in the retina, at the very back of the eye. This damage can eventually lead to complete blindness. And here's the kicker. As of right now, there's no cure for it. This is exactly why a potential new treatment is such a big deal. The current methods are all about managing the disease, not curing it. And they can be pretty intense. We're talking about injections directly into the eyeball, laser surgery, and of course, the constant stress of monitoring blood sugar. So now that we know how serious the problem is, let's turn to the good news. This is where a brand new lab study comes in, offering a potential new way forward. And this, folks, is where the story gets really, really interesting. So here's the headline finding, published in the journal Pharmaceutics. It turns out that semaglutide, that's the active ingredient in Ozempic, seems to have a direct protective effect on our eye cells. And get this, it appears to work completely separately from its day job of lowering blood sugar. The way they figured this out was actually pretty clever and direct. Scientists took human retinal cells in a petri dish. They treated some of them with semaglutide, and then they put all the cells in a really tough spot, a high-sugar, high-stress environment that mimics the conditions that cause retinopathy. Then they just watched to see what happened. And the results were, frankly, dramatic. So let's dig into the how. What exactly is this drug doing at a cellular level to defend these tiny retinal cells from all that stress and damage?
Okay, to understand this, we need to meet the main villain of the story, something called oxidative stress. The best way to think of it is like rust for your cells. It's when these unstable molecules called free radicals start causing damage, and this process is one of the biggest drivers of diabetic retinopathy.
And here it is, the first jaw-dropping result. The retinal cells that were treated with semaglutide beforehand were twice as likely to survive that harsh environment. Twice! It's like the drug gave them a cellular suit of armor, making them tougher and way more resilient.
And when they dug a little deeper, the numbers got even crazier. They looked at something called apoptosis, which is basically programmed cell death, the cell's self-destruct sequence. In the untreated cells, about half of them hit the self-destruct button. But in the group that got semaglutide, that number dropped all the way down to just 10%, an incredible difference.
And now we see why. The drug went directly after that cellular rust. The production of those damaging free radicals, it plunged from about 90% in the stressed-out untreated cells down to only 10% in the treated ones. So semaglutide was basically acting like a powerful shield.
But that's not all. It gets even better. The study found the drug also cut down on other harmful gunk in the cells. And it actually kicked the cell's genes into high gear to produce more of their own natural protective antioxidants. And maybe the most hopeful finding of all, it showed signs that it might even help repair damage that's already been done. Okay, so that's what happened in the lab in a petri dish. It's all incredibly promising, but what does it actually mean for patients in the real world? Let's see what the doctors and specialists on the front lines have to say. The study's lead author, Dr. Iana Anastasiou, really zeroes in on the most exciting part, not just preventing damage, but potentially repairing it.
But she's also clear about the crucial next step. This has to be confirmed in large-scale human clinical trials.
Then we have an independent ophthalmologist, Dr. Benjamin Burt, who points out why this is so fascinating to scientists. He says, look, we know these drugs lower blood sugar, but this study suggests there might be a completely different way it's protecting the eye, a whole other mechanism working directly on the cells. And that's a huge finding.
And this is a big one. Dr. Jonathan Gloth, a retina specialist, basically says that these lab results aren't just some theory. They line up with what he's already starting to see with his own patients. In other words, the science in the lab is confirming the anecdotal evidence from the clinic.
So the bottom line is this. We're at a very exciting, but also very early stage. This lab study is a fantastic starting point. It gives scientists a powerful hypothesis to work with. But now comes the hard part. The rigorous work of clinical trials in people is needed to prove it. So we'll end with this thought. We are literally watching a class of drugs evolve in real time. First, they were for diabetes. Then, they became famous for weight loss. And now, they might be a defense for our vision. The next chapter in the story could redefine not only how we manage a disease, but how we protect one of our most precious senses.